Hey everybody, welcome to the stream tonight. Um, Good to be back. 2 days in a row. Just making sure everything comes up and looks good. Um, like we are good. We're live. All right. Um, First of all, thank you guys for being here. Um, I was pretty sick last week, so I'm still actually recovering from it. I'm still pretty tired today, and feeling still a little bit fatigued. Um, so when it's almost time to stream, I'm like, oh, do I just cancel it? I don't want to cancel today. So anyway, yesterday we had a lot of fun. We experimented with a couple of different tools for doing typing. We looked at Typebox, and then we went back to Superstruct. And the reason we went to Superstruct from Typebox is Typebox actually added 92K worth of JavaScript to our project type, where Superstruct adds 4K as we're using it right now. I imagine it would add more if we were using more features, but what we're doing is pretty simple. And so it just seemed like a really heavy price to pay, 62K, for the simplicity that we were using. Like Typebox has a lot of amazing things in it. And that was one of the things I called out yesterday was don't pick a package based on like what it does to your bundle size. Bundle size should definitely be a consideration, but don't make decisions solely based on bundle size and things like that. You need to weigh all the trade-offs. And Typebox has some amazing things about it that I really loved. And when I thought it was only 200K, I was like, how is this even possible? It's not 200K or 200 bytes. Sorry, 200 bytes. So 92K. When I thought it was only 200 bytes, I was like, how is this impossible? So it actually wound up being bigger than if we just added Zod to the project, which was a little bit crazy to me. But you can go watch. But there's a reason why tree shaking doesn't work with things like Zod and Typebox, and it's because they expose these objects, and everything is exposed through those objects. And so the tree shaking can't shake away the stuff you don't need. Anyway, recovering from COVID, yeah, definitely. Unfortunately, it's going around right now. So just make sure you're protecting yourself. Whatever that means. Just take care of yourselves, right? Make sure you keep your immunity up, and just be healthy and do healthy things, and you should be good. But yeah, thank you for asking, Schizophrenic Web Developer. I love your name, man. I think I've commented on it every time I've seen it, but it's a good name. It's literally how I feel when I'm developing most enterprise level solutions, right? There's always like 10 things going on at the same time, and you're always being pulled in every direction, and it feels like you don't know who you are from this moment to the next because you're just always doing things. Such a good name. Anyway, so we got through the type stuff, and basically this is all we're using from Superstruct. So we've got this service response we get back from the service. And then it gives us back an array of objects. We're saying, hey, these objects are nullable. Or it's got a value and value ID. These can be nullable. It's also got a variable and a variable ID, and these have to exist. And then we created this parser. And the reason I like to do stuff this way and expose these parsers is we were able to just quickly make the changes here from Typebox to Superstruct and only change this file, and everything else just stayed the same. And so that was a huge win. And then the last thing we did is we added this filter nullish and empty because a lot of the data we get back, and we can go take a look at this right now. So we're going to take a look at our site, and we've got it up and running right now. If I decode this VIN, so before we parse the response, we get 136 responses, right? A large number of them have nothing for the value ID. So the value ID is either an empty string or null or things like that. And it just seems really weird to not, to introduce nulls and empty into our response. And so we wrote this piece here, this filter nullish and empty, but we created this type. And if you guys haven't used map types too much in TypeScript, this might seem a little bit crazy. But all this type does is it's a generic type, and we say, hey, the generic type has to extend object. So we want an object. If it doesn't extend object, just give back the type, right? So, if we do, type num nullish, right, equals filter nullish and empty number, we'll see here that num nullish is actually just a number, right? So we're getting back just that number type here. However, if we do another type, like say type test equals filter nullish and empty, and here we do, A is an optional number, B is a string or null, and C is a Boolean, and D is a number or null, right? So we've got a couple of things here that, we would have to check A for undefined, right? We would have to check B for null. We would have to check D for null. If we run it through this this type here, basically what it does is it turns it into this number where we remove undefined and null, and where we remove null and things like that. So how it doesn't look very pretty here, but basically it gives us the ability to set the return type here, so that when we look at our stuff here, right, so we get a service response back from the HTTP service, and then we log it. This map right here returns this value, right, of so we get back a value of string or null and things like that. This map turns around and turns, string or null into string, number, right? And so it allows us to know that, after we've gone through here, we don't have to check for those values anymore, right? We don't have to check for null anymore. And we can see that in the browser. So this is what we get back from the service. After we run through that function, you'll see here that our value has something in it all the way down. We also went from 136 items down to 55, which is a much more manageable number. And so today what we want to do is take this value, or this array of, honestly, it's almost like key value pairs, right? Because if we take a look, for example, right here where it says Chevrolet, this is the key, the variable is the key, the make, and the value is Chevrolet, right? And then here, like General Motors is the manufacturer, right? General Motors, the manufacturer. And then here we've got the model, which is a Silverado LTD, right? And so what we want to do is turn this stuff into an object that we can populate our stuff with, right? Um, so how do we do that? Um, well, first of all, let's just grab what we can get here, like make and model, right? Um, and we've also got like a series here. So what I'm calling the model is actually the series plus the model. So this is a Chevrolet 1500 Silverado LTD is what it is, right? The 1500 being the truck size, right? And then we've got a trim value of LT, right? So it's got a special trim badge on it. And we can, so before the, before the stream, I was taking a look at a couple of things. And so, let's generate something more recent. 2012 Land Rover. So here's another, I mean, it's not that recent. It's a 2005, right? 19 years old. We like a random VIN. The problem with random VINs is, I mean, it's since 1980 till now, so they're going to tend to be more towards like the mid 90s to the early 2000s, instead of outliers towards where we are, right in 2024. 2013 Honda Accord. That's not too bad, right? So we'll copy this. I mean, I'm saying it's not too bad. It's an 11-year-old. It's an 11-year-old VIN, right? So when we hit this, and let's go ahead and just clear. Well, let's not clear this. Let's minimize this, right? So when we hit decode VIN, again we get 136 items, but it gets cut down to 45 items. And again, we can look. Here's our Honda. It's associated with our make. We can probably add a manufacturer to our stuff, but it's a Honda Accord, which I believe it told us it was, right? So this was a 2013 Honda Accord. When we look, the stuff that we get back it's definitely a Honda Accord. It's definitely 2013, right? And we've got the trim, but notice we don't have a series on it. And the reason we don't have a series is that it's not a so the 1500 Silverado, the Silverado is, or the 1500 is kind of like the truck series, right? The 1500 is the size when you think about it, and then the Silverado is kind of the special badging, stuff that they do on that 1500, right? There are other, there's like the CK 1500 and stuff like that within Chevy trucks, right? But we get all sorts of other stuff in here. So it's a Class 1C vehicle, which means it has to be between 4,000 and 5,000 pounds, and things like that. From where do I get this data? So this data is available to us for free through the vpic.nhtsa.gov. So let me give you. I'll give you this, and I'll put this in the chat for everybody, right? Just so you guys can go check out the site. But we'll go check out the site too, and just show you. So this stuff is all available for free, right? You and I. Interesting. That's not the site that I wanted to go to. Let's just try the NHTSA.gov site. And inside of here, we should be able to search and just look for our VIN decoder. So this is how you can get into the VIN decoder, right? And here's the site to share with everybody. But through this, I found the API. And the API, you can get the link right out of the repo. So yeah, and we're going to be cleaning up the data and turning it into an object that we can use rather than kind of this ugly. So this is the fun thing about, like, if you ever work with government entities, and I've done that quite a bit over the course of my career, they quite often never follow standards, right? So like the structure returned here is flexible, right? That's the benefit it's got, but it's really, really hard for consumers to work with, right? And that's one of the difficulties that we've got here, is that they've created something that's easy for them and it's flexible, right? They can add any property at any time they want by just adding a new value ID, a new value, a new variable, and a new variable ID, right? So, we can see here that the make is 27, this is 28. So obviously they're using like an incrementing key, right? And so if they wanted to add something new, like if we look down here, we can see this is variable ID 153. And there's going to be something on their website somewhere that tells you what all of these are and what they mean and things like that. So it's very, very friendly for them to add new stuff to it. It's not really, really friendly to consume, right? And typically you wouldn't be doing this cleanup in the client side, but because we don't have a back end, typically what you would do with a VIN decoder is, well, if you're doing like high volume VIN decoding and you need, like a crazy number of nines, like 6 nines or 9 nines of uptime, right? You're not going to rely on the internet to do your VIN decoding. You're probably going to pay for a service that you install locally, that you get updates to, and things like that, so that your VIN decoder is always there. But the other thing you want to do is, a lot of times when you use these VIN decoder services, there are keys. Because the National Highway Transportation Safety Administration, right, they're providing this as a service for free. They've probably got connections rate limited, but I don't have an API key. If I had an API key, then we definitely would have looked at setting something up on the server and protecting that key and stuff like that. That's kind of where we are right. Well, that's not kind of. That's where we are right now. I don't know. I've been talking with people. I soften a lot of what I say just because of the way I grew up, right? So I'll say things are kind of, or things like that. No, it's where we are. Let's get in and start converting this object into something that we can use. So we need to basically build a parser, right? And this parser would typically be done on the server backend. I guess you could do it in the client. One of the benefits of doing something like this in the client is that you save a whole bunch of processing time by offloading it, right? It's like thinking about just, you're offloading everything out to a whole bunch of other computers and using their processing power, and then collecting the data and using that data that's valuable to you, right? So you're using up, their processing power instead of, burdening your server. That's one way to look at it, which might be a realistic consideration if, say, you built something that needed to do, I don't know, like a crazy number, like 20,000 VIN decodes a minute. That seems crazy, because I think you would go through all the cars in the U.S., well, even in the world, right, within a short amount of time, doing that many Vindy codes a minute. Um, but you know, when you're hitting that level of um, traffic and stuff, then it gets into the realm of, well, I'm generating that much traffic, which means I've got that many devices connected to me, and those devices all have processors. Can we use their processors to help us get better data as because we're ingesting a huge amount of data, right? Um, so there are considerations as you scale systems, right? Most systems that we deal with on a day-to-day basis, even at an enterprise level, you're not dealing with that level of scale, right? Where you're thinking of something like a Meta or a Netflix or a Google, or right, where they get so much traffic per minute that 2 or 3 bytes winds up making gigabytes worth of differences over a significant amount of time, right? And so I don't know, just things to think about, right? Like where should things be done? And these are the, like, when you want to start moving into more senior positions, these are the kinds of questions that you should know how to answer, right? Um, so where should this be done, right? And you should know the trade-offs for your decisions too. So anyway, I'm distracted. Let's get in and talk about what we're going to do. So this map right here, filter nullish and empty. One last thing I wanted to talk about before we get into there. So in the model, we've got this Vindicoder response, right? And we're using a functional term called partial application. And partial application is really so there are a couple of important terms to functional programming. When we get deeper into functional programming, currying is a big one. And what currying does, and I'm glossing over a lot of things here, right? But let's say we've got this function, do something, right? And it takes in A, B, C, D, and E, right? And it does something with those values. Currying is a way to change the arity of a function. And so when we talk about like functional programming, we'll often talk about arity, right? And already Copilot knows what we're talking about when we talk about arity. Are you subscribing in controller, or do you use async pipe and template? Great question. Neither. What we're doing, so this obviously returns an observable, right? Decode Vin returns an observable that has all of this stuff in it. Eventually, it's going to return an observable that will have a vehicle. But how are we using this? We're using it in this Vindicoder feature. This Vindicoder feature is using signal store. Specifically, we've created a signal store feature. So if we add with Vindicoder to anything, we'll get the ability to connect to the service and process it and add, decode VINs and do all of that. So we've added with methods as part of Signal Store. And one of the cool things that comes with Signal Store is this notion of an RX method. An RX method can take a single value, it can take a signal, or it can take an observable. And if it takes a signal or an observable, it will watch both of those values. And if they ever change, right, like if the signal ever changes or the observable ever emits, it will run this function again. That's one of the first cool things that RX method does for us. The second cool thing that Rx method does for us is it gives us this basically observable pipe. But notice that Rx method doesn't return an observable. It actually returns a, well, it takes in a void, but it also returns a void, right? So when we call decode then, it's not returning anything. But what it gives us the ability to do is create an observable, and then do stuff in that observable. So here, we're logging, that the Vin decode was called. You take this out; it's not useful anymore. That was a debugging issue, right? So we're able to reset our errors. We're grabbing the VIN off of the state. We're checking the VIN if it's this, if it's a certain length. So right here, that's one problem. So that fixes that problem. So we were having an issue where even if the VIN wasn't 17 characters, it was trying to decode it. That fixes that issue. But then inject lazy also, it comes from ng extensions. This returns an observable too, but it's a way to inject our Vin decoder service. And then we can call decode on it, right? And this returns an observable also. And then we do filtering and tap response and all of this fun stuff. But the interesting thing about all of this is nowhere in here do I call subscribe, right? And I don't ever subscribe to Vin decode or anything like that. Rx method handles all the subscriptions for me and handles all of that. Yeah, so Vin decoder is subscribing. Yeah, this decode Vin, this Rx method is handling the subscriptions and cleaning up after it and all of that for me. I don't have to worry about it. And then I just put everything into the state, and you'll see how we're going to do that here soon. And so we just get signals, right? Because signal store gives us signals. And, we expect a VIN, a year, make, model to be there. And so if we go look at, one of our components here, like our vehicle details component, right? You'll notice here that all we ever do is just use our signals. So there's no observables anywhere here. And that's how we're getting our reactivity is through signals, through signal store. And we're mapping observables to signal store through Rx methods. So, very, very powerful library that gives us some really, really cool tools. And that's one of the things that I really like about it. Anyway, let's go back to this discussion on arity and stuff like that. So arity really just refers to the number of parameters in a function. So this function has an arity of 5, right? If we were to take these two out, then the arity would go down to 2, and if we were to take this out, then the arity goes down to 1. So what we've done here with partial application is we're taking in the response, but we're returning a function. And technically, this isn't partial application, right? Because we've already got the Vin decoder response set here. No, it is. So this parser returns a function that has a partial application function already inside of it, right? Because we've already applied the Vin decoder response to this is function. So this is function has an arity of 2. What that means is that to call this is function, we always have to supply 2 parameters. Well, what if one of the parameters is always the same, right? This Vin decoder response. Well, what if we just returned a function with an arity of 1, right? Where all we passed in is the stuff we cared about, and then everything that we don't care about is already set. And so partial application only works in languages where functions are first-class citizens. But we're partially applying this to a function already, and we're expecting this, right? And so this is what we care about. If we were to do traditional partial application, we would have a function that we would pass in the is function to. We would also pass in, the Vin decoder response and stuff like that. And so that's where arity becomes really interesting, because we can take something that takes a whole bunch of functions, apply the stuff that we already know about and won't change, and then only worry about the stuff that we do. Currying takes that to the next level, right? So if we were to curry do something, and I'm not going to write a function to do that, but this would be like do something curried would be something like A, B, C, D, E, right? So this is do something in a curried manner. Why do we care about doing something like this, right? Well, this makes partial application way easier, because like when we curry a function like this, we could return do something A as a partially applied function, right? And a partially applied function is just, applying stuff that we care about. And then B, C, D, and E are all we have to supply, right? We could also partially apply something like this. And then D and E are the only things that we care about. And so currying and partial application tend to go hand in hand. And these are kind of deep, like functional concepts that I am glossing over a lot here. There are a lot of other reasons to do currying. So if we had like an add function that we curried, instead of doing add 1 2, right? We could instead do add 1 2, right? So this is a curried version of add, where 1 is partially applied to add, and then 2 is applied to that partial application. And so, at some point, we could just do add 1 equals add 1, right? And then based on the curried, then really we could just call add 1 2. And so because we curried this add function, right, we took the arity and we created something like this, add 1 now just becomes, a partial application of this, right? And so now we can just call add 1 with any value, and that's going to complete the function, right? Because now we've provided both parameters, and we're going to get that value back. So there's a lot of very, very powerful things that we can do with these concepts. And so I definitely didn't talk about the partial application that we were using here in the Vin decode parser. But this is the trick that allowed us to swap out typebox for superstruct, because the API that we were exposing had an arity of 1. And so as long as the function that we gave back had the same name, right, Vin decode response parser, as long as it had an arity of 1, and the parameter that it took in was what we wanted to make sure that we were typing, then we were good, and we wouldn't have to make any changes to the service, right? Where is my service? I'm going to have to drop some stuff down here. Yeah. So we wouldn't have to make any changes to the service, right? We could still use this Vin decoder response parser, and not have to make any changes here. The only place where we would have to make changes is here in the parser. And we just needed to make sure that we were returning the right API, right? And once we did that, we were basically golden and good to go. Do they have a GitHub account? Are you talking about for this project? There's definitely a GitHub account. And if you're ever curious, I always keep a On both YouTube and on Twitch, if you ever just do the exclamation point repo, um, then you can go get the repo for what we're working on right now. Um, so everything up through yesterday is in that repo and committed, and you can go take a look at it. So yeah, um, I can't do it on Twitter. The streaming platform I'm using, you can't add a mod to the platform that I know of. And so since I can't add a mod, then then I can't use the moderator that I'm using from Streamlabs. As soon as Streamlabs tells me I can do it, then that command will be available also on Twitter. Anyway, that's the power of what we're doing here with partial application, because the function that we called before was very different, but really all we cared about was just a parser that would give us the stuff back. So where do we go from here? We need to create another model. And so we'll go into our models in here and, oh great, what is throwing errors today? Well, I should have looked into that error. Anyway, in here in our models, we're just going to add a new file. I'm going to click on that soon. And the new file will just be a vehicle response. So there we go. We've got our vehicle response. So this is going to be what we give back from our function. Let's see. Copilot chat. Copilot chat is not happy. I got a notification that it needed an update, but I haven't updated it yet. I'm building a web application where people can create account and post reviews about online workshops. I want to add a share button to share the review on Twitter and Facebook. What do I need to do this? Do I need Facebook API or Twitter? You need both. You're going to need both APIs, and you're going to need a dev key, right? Because, well, maybe you won't need both. You might be able to find a service that can do both for you. But even then, you're going to need API keys to both service, like to both, right? So you're going to need the Meta API key. You're going to need a Twitter API key, and there might be some cost associated with that now. I don't know. I haven't done either of those APIs in a long time, but I imagine just based on the way things are going that each of those APIs are probably going to pay for a certain service level. So you'll pay a certain amount that will guarantee that you can do a certain number of requests per, it really probably depends on your contract. Most of them will probably be written in requests per hour. Some, like if you get into high volume contracts, they might be written in requests per minute. But you're going to need to look up Facebook and Twitter API keys. And then there will be some API documentation. And from there, it's probably just standard. It's probably some standard RESTful service, right? Where you call a RESTful service and you provide your API key, and then you're able to post tweets or reviews or stuff like that. That would be my bet. I have to stay quiet at this point because there are other ways to do it, right? But those ways get into like TOS type issues and dubious, like what people would call gray areas. I've done stuff like that in my career because websites were abusive. I don't recommend doing stuff like that anymore. because of the way like consumer protection laws have changed, and like terms of service, especially in the US. Like the EU and other countries are probably you're a little bit safer. Consumer protections seem to be better. Um, but um, make sure that whatever you do doesn't violate terms of service. Companies are very protective of their revenue streams. Um, like ethically, that's an interesting debate and one that I don't want to get into now. Um, but just like legally to protect yourself and your company, definitely stay out of those gray, dubious areas, especially with the two companies that you're talking about, because um, unless you're like on their level, their legal departments are going to dwarf you and your company, and you don't want to deal with them, right? Um, so that's my suggestion to you, right? Stay within their APIs. Make sure that everything you're doing is you're following the rules. You're not violating terms of service. You're not doing anything like that. You just don't want to deal with the legal ramifications of some of the stuff we used to be able to do back in the good old days. We'll put it that way. Anyway, let's export a type, right? We'll call this type vehicle response. Yep, that sounds good. And vehicle response is just going to have a couple of things on it for right now. We're going to add make, that's a string, model, and that will be a string, year, and that will be a number. And this is where we'll start. We're going to iterate on this idea, but we want to start here, right? And so this is the first part. So the second part is we want to take, what is returned by the Vin decoder response, right? And we want to use so we want to be able to take this type here, this filter nullish and empty, and we want to be able to use this type to yeah, that's what we want to do. So we want this filter nullish and empty type. So this is going to be a utility type. So we're going to pull it out of here. But we want our vehicle response to have a function that can take this array and parse through it and give us back. Right now, we're just going to do a year, make, model, and trim. That's what we'll start with. So year, make, model, and trim level. And so that's what we're expecting to get back. And to do that, we need to know what this Vin decoder response gives back. And so to do that, we need to go learn some more about superstruct, right? So within superstruct, maybe in the core, types, maybe it's in types. So like object type, here, right? So if we do this, it gives us this. Object structs validate this, but how do we use utilities? Is that what we're looking for? We can assign one. Deprecated, no. Dynamic, no. Lazy, no. Omit, partial, pick, no. Coercions, TypeScript. Maybe TypeScript is what we want to describe. This mistake will fail to The describe utility returns a type representing a struct for a given valid value type. This allows you to ensure you're writing your struct definitions properly. For example, oh, that's cool. That's very cool. So describe gives you some type safety here. So we've got this service response that has results of unknown. Very cool. But what we really want to do is we want to export a const vin, or we want to export a type vin decoder response. Is it alt that allows me to change that? No. Vin decoder response, right? And this we can just infer. And I need an S here. Infer. We grab infer from there, and then we should be able to just say, hey, infer vin decoder response. Does that work? Let's go take a look again. I may need the type of. Yeah, I do need type of. So here we just infer type of vin decoder response. And so now if we look at our vin decoder response, it's kind of ugly, to be honest. But that gives us some nice nice abilities down the road. So the other thing we need is in our models, let's get a new file. And this file is going to be, for now, we'll just call it, I don't want to call it utility, because utility and shared kind of, when you name something like shared or utilities or something like that, basically what you're saying is, hey, this is a kitchen sink. Throw anything you want in here where you don't know where else it goes, right? Let's turn this into a God object, right? You may as well just name your stuff God object if you're going to do shared or utilities, right? And again, this is an opinion, and it's one that where there are always times to break this, right? Like you'll go see utilities and shared and different things. In fact, you'll probably see right here, I'm breaking my own rule, right? Like shared UI. So, but I'm always careful about throwing shared or utility in a name. So what we're trying to do is here, we want this filter nullish and empty. So what I probably should do is instead of doing that, what we should do is just name a new file and just call this filter nullish and empty, right? And so then what we can do is we can go back to our service. And in our service, there it is right there, we can grab this type. And, there are a lot of times where you might be tempted to optimize early. My suggestion to you is don't make optimizations like this until you have to, right? Keep your types close. And then when you need to share the types, then look at where they should go. But don't move your state, don't move your types, or don't move your components further than you have to. And this is a big change from the way I used to work. Like in the past, um, I would recommend, you need to sit down and you need to map everything out and make sure you know where everything belongs and all. Eh. Um, you wind up with these big, huge documents that nobody reads, nobody cares about, and everybody ignores anyway, right? Um, so my new, my new, you can call it modus operandi or whatever you want to call it, right? Is put things as close to where they are used as possible. So if you don't need to share something, put it right next to the thing that's using it, and then eventually, if it needs to be shared, move it only as far as it needs to go to be shared, right? Um, and you'll find that you tend to develop better libraries and stuff that way. You know, I'm not saying don't put any forethought into things either. It probably sounds like that. Um, that's a great way to fail, right? A failure to plan is a plan to fail, right? I still believe that quite a bit too, but anyway, so we're going to export, and we're going to export. We're going to call this parse. We're gonna say parse vin decoder response. And we're gonna call this a function. I used to make everything anonymous functions. So const parse vin decoder response equals blah blah blah, right? I don't care as much anymore. Function and parse. There are benefits to either way. And I'll pick one way over the other if there's a benefit to it. Actually, I think I'm colliding. Nope, I'm not. Okay. Um, let's name it even a little bit better. Let's convert bin decoder response to vehicle response, right? Man, that is a beautiful name. This is going to return a vehicle response. Boom. Right. And you might be sitting there going, well, why don't you just do class, vehicle response, add this stuff to it, and then, your constructor calls a function, parse bin decoder, right? Uh, um, I love objects, but I grew up on like C++, um, Java, C Sharp, right? So object-oriented programming is not a new thing to me. But one of the things that, like, if we do, class A, right? And then somebody eventually is going to come along and they're going to do class better A, and that, of course, extends A, right? And then you're going to get somebody else who's going to come along and go class even better A extends better, right? And so then you wind up with this crazy hierarchy, right? Uh, if I don't do this, then this can't happen. And all of those extends keywords are the strongest form of coupling that can happen, right? So like if we go here and we have A as a string and we've got a constructor takes an A, right? And then even better A means it takes a signal, and this is a signal string, right? Great, and we just start with an empty signal there, right? And then even better A comes along, right? And in the constructor, again, we take in the A, we do super A, but we also do, this dot A signal dot set A, right? And then, even better A comes along and it adds ABS, right? Which is a new behavior subject. And this is a string, right? And it starts with nothing. Inside of here, we've got a constructor where we call super A, and then, we do this dot abs dot next, but we also do, effect, right? Because if the other one changes, this one needs to change too, right? So we add our effect in, and in our effect, right, we just do this dot abs dot next, this dot a, right? Anytime a changes, and so and this is a signal, right? And so now we've got this crazy coupling, right? Where, oh, guess what? This really shouldn't be a string anymore. This is an integer, right? And you know what? B is our string now. Well, now we've broken a whole bunch of stuff. Or this has to be number, right? Well, A is a number and B is a string. But now we've got to go in here and we've got to change this to a number. And now we've got to say, hey, B is a string, but it's optional, right? Because we're trying to maintain some backwards compatibility. So we say this dot B equals B or an empty string, right? But wait a second. We've broken some stuff, right? Because we've said A is a signal here. We can't do that. So now we've got to change A over to a number here. Right? And so now we can call super, but now our signal, now it's not a string. Now we have to decide, do we keep it a string? Do we not? Well, no, it's really a number. So then now we've got to decide, oh no, is it an empty string or is it a -1 or is it a 0 or what is it, right? And this change to class A has rippled through our entire, right? And it gets worse as we go further and further down the chain. Yeah. The first rule of utility naming is that there is no rules. Yep. I found your approach kind of over time on a recent greenfield project. I feel like it has mixed results, but I'm making the case to my team that is a good thing now. Everything has mixed results. And I agree with you. It does have mixed results. So my argument is often it's not the best that's possible, but it's the best that we've got, right? There are always trade-offs, right? And one of the big trade-offs to putting things close to where they're used, and then moving them later, and there's always somebody on the team who's just a crazy, they go against the rules for whatever reason, right? There's always that person, and you know who they are because you've worked with them. That person's going to wreak havoc on your code base doing what I just recommended, right? So you've got to be way more vigilant in your, your code reviews, right? Your MRs and your PRs, right? Whichever, whatever the platform that you're using calls them, whether they're merge requests or pull requests, right? You have to be way more vigilant there. It requires more vigilance from like upper, senior level people, and there will still be somebody who figures out a way around it. and you can rewind. You can't rewind. You can wind up with like spaghetti or a big ball of mud, right? Um, but even if you go and lay everything out, that same person's going to just go and ignore the rules. And again, right, spaghetti, ball of mud. Um, it's just, you know, the best a program ever is after you've just set up the template. That's the best it's ever going to be. Anything after that is just adding entropy to the project, right? Um, and as humans, we're incredibly good at adding entropy to our projects. Um, and once a project is fully overcome by entropy, um, that's when we start calling it a legacy project, right? And then the rewrites on the way is going to fix all the entropy that we threw into the old. That's not true, right? Um, it's going to be beautiful in the very beginning, and then you get one coder in there who's adding a little bit of entropy. A second coder doesn't double the amount of entropy; they actually multiply, right? So it's a multiplicative result, right? So when you throw in three coders, right, it's not that you've tripled the amount of entropy. It's a logarithmic scale of some sort, right? Maybe it's exponential. Who knows, right? But it's definitely not a linear progression, right? One developer adds this much entropy, two adds this much, three adds, right? It's more of an exponential scale. You might get lucky and it might be logarithmic, or eventually it levels out because you've got so many developers fighting fires from all the entropy added by other developers that you really can't add a whole bunch of new code, right? You get more of a logarithmic stuff going on like that, right? But that's just the reality of software, right? The more people you throw at it, the more entropy you're throwing at your project, and the quicker it becomes legacy software. Um, and that might seem like a little bit nihilist or whatever, and it probably is to some extent, right? There are a lot of good practices that you can follow, um, but you see these tech posts all the time about if you knew what was really going on in the software that you used, you'd be horrified, right? A good example of that I just read about recently, is, I don't know, like, I like strategies type gaming. I'm not, right. I'm getting to the point where I'm old enough that anything that I have to do quickly or that has like quick time events in it, that's not for me anymore, right? When I was younger, I was okay with that kind of stuff. I just don't care. I'm not there to try to time a button press exactly right anymore. Um, I'd prefer to think my way through things. There was an amazing game called Balatro. If you guys haven't seen it, you should go check it out. It's one of my favorite games. It's basically it's poker, but the jokers that you have in your hand change the way you play poker, and then you're trying to get each hand that you play generates points, and the jokers control like how the points go, right? Um, Balatro is basically one giant if statement, according to the dev who wrote it. And he's horrified, right? He's like, I'm so embarrassed because it's just one giant if statement. If I had to do it all over again, I wouldn't do it that way. And it doesn't matter. It works, right? But that's kind of what we're talking about here, is that, you go in and you take a beautiful piece of code that does nothing and you start adding entropy to it and creating problems, right? So yeah, the strongest force of coupling that can happen. Yep, me when I met my. Oh, okay, that's awesome. Congratulations on that. Um, almost gold stakes on most. That's awesome. I'm just getting into the black stakes. I haven't had a lot of time to play recently, um, and I've seen a JS equivalent. It's wild. Before I read it, I tried signals based approach, and it was a mixed bag. Yeah, and that's the thing, right? Like the best code that exists in my head is infinitely worse than working code that's in a project. And I was just having a discussion with a developer at work today about this too. And she was talking about, we've just upgraded Angular across the entire project that she's in, and she's like, how do we get the devs to go in and change everything, and how do we convince PMs that this is worthwhile, and right? Um, and we had a bit of a discussion where why, right? The code works. If you go in and change things, then that's, you're incurring testing and all of this other stuff. Let it be. And then, when you get in and you change a file, then take the time to make the changes, right? But, doing these big bang changes wind up being expensive. They're huge they're huge testing. But you've already got the testing budget worked into your sprints. You've already got the testing budget worked into the fact that you're touching the component. Why not take that time to do it, right? Because again, the best code that exists here is still infinitely worse than code that's out there and working. So, be hard on yourself, right? But allow yourself to make mistakes, allow yourself to learn, but always push yourself to be better than you were last time. But anyway, getting back to what we were talking about here, why don't I do object-oriented approaches? This is the reason why, right? As soon as somebody comes along and extends and then extends, then, any change in A forces a change across the entire code base, right? That's why this is the strongest form of coupling that can happen. And this is why everybody tells you, prefer composition over inheritance. That's a good reason right there. Why you should always prefer composition over inheritance, right? And I'm cherry picking and I'm doing some other stuff, and people will definitely tell you, hey, there are good ways to get around this and handle this. Absolutely. Do I want to deal with them? Maybe. Do I expect everybody to? No. So yeah. The big thing I had to learn as a junior was to only really refactor to new approaches during fixes for things that were too messy for a quick fix. And that's the tough thing, right? Like I was saying yesterday, while I was sick last week, I spent a lot of time watching Prime. And if you guys have never watched the Primogen, huge fan of his. But one of the things that I watched was talking about 10x developers and like what a real 10x developer is. There's that channel where the guy, pretends to be different people that exist at development companies. I think it's like developers are human or two or something like that. I can't remember the exact name. I watch his stuff and find him hilarious. But he did a video on like a true 10x developer, and Prime reacted to it. And at one point in the video, he's like, "Oh yeah, that I rewrote that over the weekend, right?" I've been that guy, right? That I was like, "Oh, you know what? I could do this so much better. Do a whole rewrite over the weekend, put it in," and everybody's like, "What the hell happened? Why did this change?" Right? "Oh, I had time over the weekend." Well, why did you do that? There's a whole bunch of other things that you could do. You chose to rewrite this. So I agree with you. Learning to focus your talent is really important. And to be honest, it's still something that I can struggle with, right? Because I'm one of the ones who I want things to be perfect. And things are often never perfect, right? So yeah, definitely, be careful about your rewrites. You may be producing 10 times the code of anybody at your company, right? You may be a 10x developer, but are you that 10x developer that's making things 10 times worse for everybody? Or are you that, developer that makes the entire team 10 times better, right? because there is a big difference. Like if you make yourself 10 times better, that's one thing, right? If you make the entire team 10 times better, that's a whole other level, right? And it's not that the making the entire team is not, again, it's not linear, right? There's exponential gains there to making the entire team better. So learning where to focus your time and your energy to make your team better instead of just yourself is hugely important too, right? So here we'll pull in a filter, nullish, and empty. And the type here is going to be our VIN decoder response. So there we go. So now we've got our function that's going to go through and parse this out. And already Copilot has some ideas. So this is interesting, and let's take a look at this code that Copilot wants to write, and let's talk about what this code does versus another approach that we could take. So if we look at this code, it goes through and it goes year, right? And so it wants to go through the response, which is an array, and find an item that's a variable, right? And if that variable is model year, then it wants to grab the value. Well, first of all, I don't think it's model year. We can go take a look. So if we decode this VIN, we look in here, here's our year. Well, they did call it model year, so it's okay, right? It understands. Make, model, and trim, great. But we've got some problems here. To get these 4 values, we're iterating over this array 4 times, right? So worst case scenario, right? For these 55 items, that's 4 times 55 worst case scenario, right? But we're at 220 iteration, 220 comparisons, right? And in the worst case scenario, it doesn't find any of these, right? And so we get back undefined for everything, which is not good. Could we do better? I think we can. I think we can do a lot better. The best solution that I think we could come up with is, what if we just did a reduce on this object here, right? So we just went through and we reduced it, and for every object, we would grab this variable, we would turn it into a property on the object, and then we would turn around and set the value, right? So we would wind up with an object that has error code with a value of 1. It has error text with a value of 1 check digit in the 9th position, right? It has a variable, a vehicle descriptor that has a value on it, right? And then make has Chevrolet on it. And so we would just go down and basically we would turn all of this stuff into an object that has the variable name and the value, right? The variable and the value. That's what we would do. And I think that's the first way to go. That's going to give us the first solution, is basically to convert this giant array into a record string, right? Because everything in here is string and string. So let's do that first, right? Because what we want to avoid are situations like this, where we want to pull something out and um, we're we can think of this in kind of database terms, right? We're doing an unindexed search, which means every search is like a full table scan. What does that mean? Well, that means to find anything, we've got to go through every item in the table and make the compare. And as soon as we find a value, we can drop out. But until we find a value, we've got to compare everything. And if that value is not there, we've got to scan the entire table, right? That's the absolute worst way to do things. What we can think about is converting this array of objects into a record string, like into a record, right? We can think of that like indexing the data, right? So we're indexing it and grabbing what we care about. So to index it, we've got to go through the entire table once, right? Once we do that, we've got the index, which is basically a map that will take us straight to the data, right? And it allows us to quickly search, right? So now lookups go from being a full table scan to one operation. We go straight there. We're trading memory complexity for operational complexity, right? In this case, the trade-off I don't think is that big, right? Because there's 55 items. That means we're going to create an object with 55 properties on it. That's not that big of a price to pay, right? If we were up into like the 100,000 or million, then that trade-off is more expensive, right? Especially when we think about, like phones or things like that don't have a ton of memory. And again, we're trading memory complexity for operational complexity, right? What do we mean by operational complexity? This is operational complexity where we scan the entire table. Most of the time, this scan isn't going to take very long. And because we know how the data is ordered, we already know that, this isn't really expensive. This becomes more expensive as values aren't found and other things like that. So, yeah. And again, right, we're talking about deeper things. So, when you're thinking about solutions, and you want to be able to present these solutions, you should understand the trade-offs. And if you start, it sounds a little pompous, but once you start saying things like operational complexity versus memory complexity, a lot of people just turn their brains off and they're just going to believe you anyway, right? And it may not be developers that do it, but it may be, it may be product people or managers or things like that that are just like, oh yeah, they've done their research. He's already talking about memory complexity versus operational complexity. I don't know what that means, but obviously they do, and right. So sometimes it's helpful to bring that kind of stuff up too. But yeah, we're going to go there. So the first thing we want to do is just convert this to a record. So thank you, Copilot. But that was horrible. And this is, when people ask me, is AI going to take your job? Probably not. Why not? Well, because AI just wrote I guess I wouldn't call it a horrible implementation. It wrote a brute force implementation, right? We can do better. We're just going to say function convert to record, right? And again, we're going to take a response. It's a filtered nullable response. We're going to convert it to a record. So convert to record has no usages. This is going to return a record string, right? And I do recommend adding these typings instead of allowing TypeScript to infer it, because what we want is we want to make sure that what we get out is what we're expecting. And I know that sounds, kind of tautological, right? But we can look at this as kind of some safety for us. If I say that I only want this to return a record string, then that's the only thing I can get back. If I write something that returns anything but a record string, we're going to get issues down here, right? And so, the first thing we can do is we can just say, well, and right away we're getting some nice things out of this. So that's awesome. So it's using a reducer. This is what I would have written. So the code is already better, right? A reducer is probably the right way to go. So we're taking the response and we're reducing it down. The accumulator, we can rename this, right? Accumulator is a horrible name here, but we can just say, hey, this is the current record, right? So that already makes things a little bit better. And this is let's even just call this our record to return, right? And this is our current, our current value. Great. So already, let's go back and rename these properly. My goodness, dude. So here, this is record to return. And this is current record, right? Or current item. Let's call it current item. So already we've got a much better place, right? Type string or null is not assignable to type string. Why is variable type string or null? So record to return, current item, like variable value. This is weird because if we come in here and I just do response, so if I do response 0 dot value, it still thinks it's string or null or undefined. Variable can be string or undefined. And the weird thing is that response is an array of string or null. right? It's got stringer null here. That shouldn't be possible. Oh. There is an issue here. Um, that's fascinating. Very fascinating. So this filter nullish and empty takes in an array of type T. But here, oh, that's fascinating. We need to make some changes. And Kittysack Quanid. I probably completely butchered your name, but thank you for following. I appreciate it. Means a lot to me. But so we've got an issue here because here we're inferring the type, and we're taking in an array of items. And so the filter nullish and empty works. The reason it doesn't work here in our vehicle response is that the VIN decoder response is an array already. So you can see there's an array down here. So we need a type that will fix that. And so what we need to do is type filter nullish and empty array t comma u. And actually, we don't even care about that. So we can just say t extends array infer u. And this is a cool thing about TypeScript, and it's already giving us exactly what we want. So when you use type declarations like this, we can say that, hey, our type has to extend an array, and we can infer the U type, right? And this could also be written, if you prefer this way. And I think if we do that, we have to do this, right? Yeah. So you could write it this way. The other way is probably more readable. But what it's basically doing is you're introducing a new generic type in your type, but you're not having to declare it here. So what we've said is that, hey, filter nullish and empty array, we expect an array, this type T, that is an array that extends a certain U. I want TypeScript to infer that U and then return an array of filter nullish and empty U. Otherwise, just give me back T, right? And in this case, I would actually go this route. And so here, now we can say filter nullish and empty array. And down here, we can also say filter nullish and empty array. And all of our problems disappear because now if we look, the type of response no longer has string or null. And the reason it had the string or null is if we go and we take a look at the filter nullish and empty, right? Filter nullish and empty was looking at the type T, and type T extends object. Well, guess what? If we do you know, array extends object. So already it went in and it was like, hey, any of the keys on the array, so any of the array indexes, right, 0 through whatever, or anything like that, that were optional, take them out, make them required. Well, guess what? They were all already required, and none of them extended null. So it really didn't do anything for us. Um, Instead, if we turn around and you know, we do this, then we're in a better place. We do have a problem here. And this is the variable right now, as it's written, up here, we're trying to do model year, right? But that's not going to work. We're going to get something like, it's going to be like response model year, right? We don't want that. Instead, we want to convert this. What we can do is we can just do right here, we can do replace that with null or undefined, maybe. That can work. No. That one should work. And the reason we're getting the array indexer stuff here is that it recognizes that down here we're setting the variable using an indexer, using this. So we have to access it up above using an indexer. Can I do as record string? Will that work? No, it still wants me to use an indexer. That's fine. I don't really care too much about whether I'm using an indexer or not. It's more about speeding things up, right? Does it have an auto fix for this? Propagate to a destruction. Okay. Interesting. We'll go one step further then. If we're going to destructure, right? We're just going to say, hey, we're going to pull these things out. And here we want our trim. And then really now we can just remove all of this stuff. Oh, I had it right the other way. Dang it. So make is make, model as model, year as year, and trim as trim level. There we go. And it's rightfully suggesting that we use a radix here. And base 10 is the right way to go. Because if we pass in a weird number, it could easily infer, that it's base 8 or base 36 or who knows what, right? So by doing this, then, we guarantee that we get the right thing. What I do want to do is just right here, let's record equals this, and then this equals record, but I do want to console log our record just to see what we get back, right? Just to debug this as we go through. I need to end on time tonight. School has started, so here in the Vin decoder service, the next thing we can do is we can just say, hey, we're going to map our response again. And now we're going to give it to convert that. And we need to import it. And the other thing we can do is we're basically wrapping that anyway. So why don't we just do that and just pass it straight in? And now we're good to go, right? So now if we go take a look at our decode VIN, boom, our response is now a 2022 Chevy Silverado LTD with a trim of LT, right? So, you know, we've run through this array a few times, right? We ran through all 136 to get it down to 55. Then we run through the 55 to turn it into a record. Then we just quickly parse apart the record, which I like. There are some other things we can do with the model here. So one thing we could do I'm trying to decide how I want to handle this. Because right now the make is in all caps. And that's because that's how we get it back. Right? And here's the object that we get back with all of the equipment on it. Why is it only replacing some? It's like vehicle type is being replaced. Trim, but like trailer type connection? How was that one up here? It's not logging out my 55 anymore. Where did I take that one out? Let's go back to the service. Did I take out a tap? Is that what I did? So we moved that. And we added that. We added that, and we added that. Oh, I didn't take out a tap. What happened is the console log that's now logging record or response was what was logging the 55 items. We can put that back in for now. And the main reason I want to do that is just to make it easier to track down, where things came from. Um, to my service, isn't it? It's right here. So here, we're going to tap response after filter. There we go. So now when I decode, now we get the 55 items. I'm curious, like, where did it's like rear cross traffic alert. Oh, I did replace, not replace all. So it's only doing the first, right? Yeah, that's the problem. Um, it's been a while since I've done this. Yeah. Me when I'm a very scummy plumber. Yeah. And that kind of describes how sometimes building RxJS is, right. RxJS is often compared to doing. Why is that an underscore? Was that just showing a space? With one or some or all of them matched by the pattern. Pattern can be a string or a regular expression. Um, if it's a string, it will replace the substring matched by the pattern. A number of special replacement patterns are supported. If it's a function, blah, blah, blah. So the search value and then the replace value. So I think if we do, instead of a space, we do that backslash W slash G. Isn't backslash W white space? I guess we'll find out when I go to decode this, right? So now when we look at the record, oh, that's even worse. That's hilarious. um, isn't there like a regex? Um, check regular expression. Sample text. What does backslash W match? Oh, it matches word, right? Is it B? I'm gonna have to go look stuff up. I like this site, regex 101. Um, there's the ECMAScript. And oh, it's \S. What was W? Yeah, any word character. That's why all I was getting was spaces. And \B is a word boundary. I always forget \S, right? And then test 1, 2, 3, 4. Yeah, there we go. So here we want that. That should solve my problem. I still got some ugliness going on, but yeah, I don't want to save them. I'm fine. So now if we decode the VIN, inside of here, yeah, there we go. So we'll probably have to do some other things here. But for now, it's doing what I would expect. You know, it's taking out all the spaces. And that's the crazy thing about replace. So if we go to MDN, right? MDN string.replace. So inside of here, it's only going to grab the first one, right? And ferret. Yeah, so here you'll notice that even though it said to do a case-insensitive search for dog, it only replaced the first ferret or the first dog, right? I think Ruth's dog became ferret is cuter than your dog, right? Because replace and this is one of the reasons why I love replace, because it doesn't mutate the string; it returns a new string. Yeah, and we're using the /g flag, but we could use replace all. That's probably better than what I'm doing anyway. Let's be honest, replace all is probably doesn't like replace all. Is my target wrong? So I'm targeting ES 2022. Let's see, target. Oh, look at that. Here we're not. We should fix that. So for the unit tests, we are targeting 2016. So our unit tests might have problems. Does that fix my issue? Like, replace all has been around since Chrome 85. Everybody supports it. Oh, you know what? I probably have to just restart this. Um, my serve probably needs to pick up this stuff. I like the new immutable operator. Yes, yes, absolutely. Two spliced, absolutely. Totally agree with you, Michael. You shouldn't be mutating stuff in place. Lib, lib. Um, there's the issue right there. This should be 2022. That should fix that. I should be able to just set the rest back. So we can do that here. ts config.base. And so I should just be able to discard this line, keep that line, and everything should still be fine. Does my compile work? Restart it again. It helps if you read your error messages. Instead of changing the target, change the lib. There we go. And the reason I went with replace all over replace is replace all communicates a little bit better than what a /g does, right? Like most people would know that, hey, that's a regex with a global replace on it, but then you have to understand that if you don't add the global replace or the global search on it, then replace is only going to replace the first instance and blah blah blah, right? It's a whole big mess. So instead of just dealing with that mess, why not just make it clear that we want to replace all the spaces? And I think this code communicates that much better than the code I had written. So there we go. We've now got basically this convert, we're getting back this response. So we can see here that we're expecting back a vehicle response. So now if we go to our feature, we can see that we're returning this observable from this switch map. This is where we're logging the response, but now we can just do patch state and do that, right? And really, we could even just patch it with response. And that should work just fine. Let's see what we actually get when we call a Vindy code. So what we're looking at is down here in our state, right? And let's go generate a random VIN so that we can a 2013 Subaru Impreza. Let's hope this is a WRX. That would be really cool. Unlikely that we generated a random WRX, but that would be cool. Especially, well, wait, no. What year was it again? 2013. Yeah, they were doing WRX in 2013. Let's decode this. We just got an LT. That's too bad. But notice we got the 2013 Subaru Impreza LT. And down here, we're just getting year, make, model, trim. We do have a problem. And the way to show that problem is on this Silverado. This should really be a Chevy 1500 Silverado. And the way we can tell that is that we've got the series in here. So the series value is the 1500. We can fix that too. Now that we've got a way to pull this apart, right? Now we can say, hey, we also want the series. And what we can do is we'll call this trim. We'll call that series. And what we can do is we can just say, hey, trim level equals series, comma, trim, dot join with a space, and we'll trim it. And we can set that as a const. So, you know, we're doing a little bit of magic here. This is the way, like another way to write this code would be let, you know, trim level 2 equal this. And then, you know, if series, so we could say if series and series dot trim or series dot length, right? Then trim level 2 equals series plus trim, right? Else trim level 2 equals trim, right? And so, you know, then down here we could put trim level 2 in. This is just kind of a little bit of a cheeky way to do that, right? So now if we go back and we decode this VIN, wait, is it not grabbing the series out of here? I put it in trim level. I put it in trim level. Oh. So we aren't adding trim level to, yeah, we did. We added trim level down here. This should really be series and model. Down here, we would call this model. And we can just call this resp model, right? Well, actually, we can just, instead of doing that, we'll just do that and that. So this is our trim level, and this becomes trim. But one thing that we're doing wrong is in the feature, this patch state actually doesn't work. And the reason is that we could be adding stuff to the state that we don't want to add. There we go. Our state, year, make, model. Do we only have year, make, model coming in? Yes, we do. Well, that's easy enough to fix. Trim. Right, so now our VIN decoder can do our year, make, model, and trim. Now if we decode this VIN, now we get the 1500 Silverado, we get the trim level of LT. If we decode the Subaru, we still get the Impreza, so we aren't getting... Oh, Premium Plus SR, Sports and Racing. What package is that? I don't know. I'm getting distracted, right? Because I've liked the Impreza. It's a fun car. So when I was younger, I was into like rally cars and stuff like that. So I like Focus. I like the Civic. I like the Impreza. The Lancer. Oh, I always wanted to own a Lancer Evo. That would have been a fun car. I love the speed clutch on the Impreza. It's a lot of fun. I don't know what trim package this is. Sorry, I'm gonna have to look this up. Oh, it's kind of an ugly package. I am not a fan. Like this is the like I like the WRX. I like the sedan body. I like the low stance. I like the low profile tires. And 17K for a 2013 car. That's crazy. This must be a nice Impreza because it's even beating the 2015. But you've got like the classic Subaru blue on their Impreza WRX, right? And like if you look at the Lancer Evo, again, like I love these kinds of cars. I love the low stance and you know 17K 2013 no way 22K for a 2021 SUV. Yeah, exactly. And like these are like the ultimate luxury buys, right? The cool thing about like the Evo and the WRX is they're all-wheel drive. Right, they've got a huge turbocharged 4-liter, like 291 horses, and this vehicle weighs almost nothing. Like they accelerate like crazy with all-wheel drive. Why would you put a 6-speed automatic in a? Why would you do that? How? And you just look at the wheelbase on these things, and um, I mean, 291 horsepower. If you like, that is crazy. How much horsepower they're putting in a vehicle that small. like the Impreza WRX. What was the again, right? Like they put a bigger engine in it. This is a 2.5 liter four cylinder, but 265 to 305 horsepower. So the Evo is getting fairly similar horsepower. And yeah, you can't even get an automatic in a WRX. Um, definitely do a sedan. As far as I'm concerned, I don't like the look of the hatchback. I know some people do, but yeah, I'm way off topic. I definitely a car person. I enjoy such an ugly package. I'm sure there are people that like. I probably, you know what? To be honest, I would probably drive that vehicle anyway. The Impreza is a nice car. So, but we did get our VIN decoder working, and we were able to talk through like some bigger concerns, right? When you're writing software, um, taking a step back from like brute force approaches and thinking about trade-offs, right? So for our trade-off, we're trading memory for speed, right? So we're paying more in memory, but we're getting better speed, right? Um, the other approach would have used less memory, right? Because we aren't building the index on top of the existing array. We're just using the existing array, but it's trading off speed or memory, right? And so those are the two trade-offs that we're making. Typically in brute force approaches, and not all brute force approaches, but in most brute force approaches, um, you're you're typically like MO to you're typically MON, right? So if we right, if you guys know your big O notation, right? So that's hilarious. But what I'm saying here is it's big MON, right? And sometimes it's written this way. Most of the time, you would just forget this because what this is, what the what this is telling us is that we're doing iterations per lookup of O to the N, right? So really, if we look at the entire response here, where we're looking up 5 things, right? 1, 2, 3, 4, 5, yeah. Then it was 5 times O to the N is the worst case scenario. Um, and that's not that big when some brute force um, some brute force can often be O of N squared, right? Um, which is pretty bad. Ours winds up being ON, right? And then it's an O of 1 for the lookup. And so if you guys don't know what big O notation means, big O notation is kind of a way to roughly guesstimate, how good your implementation is. So O of N means that in the worst case scenario, you have to go through the entire thing once, right? That's O of N. You have to go through everything once. And adding this M is often omitted. I've seen it used and omitted. At work, we'll often use it, just comparing because five times O of N is still bigger than O of N, but in like true big O notation, you often never see that, right? So it's O of N for everything, right? O of N squared is worse because that means for every item in the list, you have to go through the list. So you go, the first item, everything, second item, everything, third item, everything, right? This is often the worst. There is one worst case, but I have a hard time conceptualizing it. But there is an O of n to the n. This is theoretically the worst that your thing could be, and this means that for every item in the list, you go through the list n times, right? So if your list is 10, so in this case, right, of m, m times n, our list is 55 items, right? So in this case, I guess it can also be O of m times n, right? But this is 55 times 5, which winds up being what, 275? In this case, O of n squared would be 55 times 55, right? So you would go through the list, whatever that number is, that's 3025, right? Copilot's not even going to try to do this one, right? 55 to the 55th power. This is so incredibly slow that you would kill any system doing this, right? And here, this winds up being 60 operations, right? So this is the use of like comparing this stuff, right? We don't have an O of n squared here. Our two comparisons are this to this. So we can say that we're about 4.5 times faster than we were before, right? So at our size, that kind of optimization doesn't mean a whole lot because the amount of milliseconds that we're saving for this optimization is probably dwarfed by the amount of time it takes for the call to come back. And we could do that with traces too, right? We could run timers and traces and figure out, the browser has some really good tools for, figuring this kind of stuff out. However, as this number goes up, right, if we say, if we say, n equals 100, then this becomes 500 versus 101, right? Operations. Well, and actually it's 105, right? And so now we're getting into the order of, now we're not, 4.5. Now we're getting closer to 5 times faster, right? And as it gets up into 1,000, this becomes 5,000, and this becomes 1,005. So we are staying fairly linearly the same, but at this point, the amount of milliseconds that we're saving, right? If this is 5,000 milliseconds, that winds up being 5 seconds versus 1 second, right? And now it's starting to show, how it's getting better. And so that's, and again, those aren't exact numbers, right? They'll never be exact numbers, but they give us a way, and that's kind of what big O does. When people are talking about big O notation, it gives us an idea of, kind of ballpark how much complexity are we saving, right? And you can also talk about operational complexity, memory complexity, and things like that, and use ON also, right? Like big O notation for that too. But anyway, I definitely need to end. I'm a little bit over. Thank you guys for being here. We'll be back Thursday. We've got our VIN decoder in place, and I'm actually really happy about that. Um, um, some things I want to take a look at is potentially grabbing like engines and fuel types and things like that, maybe in the future. But right now, we're in a good place to start exploring um, what happens if we go server side rendering, right? TBD Gamer. Oh, you do karate on Mondays. Um, that's awesome. That's amazing. Like real karate, karate, um, or is it like a form of mixed martial arts or things like that? That's awesome. That's that's one of the things I've always wanted to do, and maybe I should. Um, like my daughters are in high school now. Well, one of them is. The other one's getting close. Might be good to just take some self-defense classes. It's karate with some MMA and jujitsu. Oh, that's cool. Really cool. Um, it's really rare to find pure martial arts taught anymore. So here in the city where I live, they do teach like a pure Wing Chun kung fu. But that it's pretty rare to find like pure martial arts anymore. Most of them do a little bit of MMA. And meet some adults. It can be really rewarding and challenging, and that's and it has long-term health benefits too, right? And mental benefits. There's just a lot of good stuff to doing like a disciplined sport, like any of the martial arts. So that's awesome. Thanks for joining at the end. I am ending now, um, but really appreciate it. You guys have a great evening. We'll see you Thursday at 5:30 p.m. Mountain. Um, and I'm looking forward to it. I think we're going to jump into SSR and look at what can we do to really just mess with Angular and get our initial bundle size as small as possible. I'd love to get like a sub 10K initial bundle size. Thank you for that, TBD Gamer. I'm starting to get a little bit, you can probably hear some hoarseness. I'm still recovering. I'm still a little bit just fatigued, which is crazy, right? To have an illness hit you that hard. But thank you for the kind wishes. You guys have